Thanks, Randy, for introduction. So actually, I'm Yonggang. I'm here to share some of my latest work in AI and digital infrastructure for a sustainable future. So actually, Professor Borden laid out a good framework for my talk. As I look at two aspects: the twin transition between the digital transformation and sustainability challenges. So I will start with the first one. AI-derived sustainability challenges. So actually, we partly through the COVID, we live on this digital transformation. Without digital tools, we will not be able to survive. But at the same time, as Prof. Borden mentioned, actually, by not going out, actually did not reduce the carbon footprint that much because we actually replaced our human activity with a lot of digital activity that in a way to actually increase our carbon emission. So let me look at some data. Actually, one of the key enablers of digital service and digital transmission is the data center, which is a building or a set of buildings which houses computers for our digital services. So these gigantic data centers actually is a energy Godzilla in a way. It consumes huge amount of energy to run and operate these data centers. So let me using data center electricity consumption as a percentage of the total power consumption as a proxy to see how big the problem is. So let's look at globally. There was some studies shown by 2030, the data center would consume close to 8% of all the electricity that human being has been used, which is on par with the airline industry. And so if you look at a small nation like Singapore, for obvious reasons, we have become the data center hub in the world. Actually, by 2030, we predict that in Singapore, data center will consume close to 12% of all the electricity in Singapore, which is a big challenge. Because of this prediction, actually, Singapore government in 2019 decided to put a moratorium on new data center builds. Actually, that creates opportunity for Malaysia and Indonesia over the last 3 years. We see tremendous of data center built in Malaysia and in Indonesia. So actually, all of these growth in terms of electricity consumption are because of this digital transformation I call ABCD, start from AI, big data, cloud, and digital transformation. So these actually aggregate the demands for the electricity. But the latest one is further make the problem more challenging is the large language model. This morning our speakers talk about the large language model. On one side, these LLMs is fantastic. It hopes us can solve a lot of problems, but it actually had some cost. So actually, recently I conduct some study on how much energy of these large language model would consume if we want to use them or even want to train them. So let's look at the top 3 large language model on the market right now. The Llama from Meta, Facebook, and ChatGPT from OpenAI, and the Google Palm. The parameter size is 65 billion and 175 billion, and the Palm is 540 billion parameters. So if we plot the amount of energy cost to train this model in the pre-training stage, roughly is scale up as the parameter size or the token size we use to train the model increases. Actually, this actually escalate as the model size, and we see the model get larger and larger, and the amount of energy it consumes actually increases, if not linearly, at least sublinearly. So this energy consumption then will be translated into the carbon emission. So if you look at the amount of carbon emission it generates for this training, actually it's something interesting happened here. It's not linearly growth anymore. So if you look at the Facebook and OpenAI, the carbon emission mostly from category 2, actually is substantially higher than the carbon emission of Google. That actually triggers a question, why is that way? And so for people who are working in the IT industry, we all know that data center is basically something which Google guarded as the most secret technology have in their portfolio. Actually, they have the best data center technology in terms of energy efficiency, in terms of the technology advancement. So actually, they are really good. Google is really good at building the green data center. So basically, their carbon in data center, there's a parameter called CUE, carbon usage effectiveness. Is the per kilowatt energy consumption. It's measured the carbon emission per kilowatt hour electricity consumption. Actually, Google is ahead of all its competitors in that category. So actually, that points a very good way of one can possibly to reduce without sacrificing the carbon emission curse or whatever you call it when your model size grow up, and this is a good thing we want to see in the market. So this is just one case, especially the leading case right now, how the carbon emission of these large language models will evolve. So if moving forward, if you look into the future, so here I just want to, as a practitioner in the AI and the ICT industry, I want to offer some hypothesis for our economic colleagues to think about. Moving forward, what are the future? Because we foresee that the AI generated content models, AIGC, which is the topics of any forum nowadays, how that the energy trends will be looking at. So if you look at a standard process of doing the AIGC, you have two stages. First, you have a lot of data. You train that in a data center, which is a facility consumes energy. That's the first step. You generate that model. And then second stage, you deploy that model to serve in people's requests. Like when you and I, we log on to open chat and our prompts, actually, we are in the second stage, is the inference stage. So actually, there are different dynamics in terms of energy consumption. If you look at the training stage, it's actually more or less fixed, because these are the price you have to pay in order to train this model. If you look at the x-axis is the AI adoption, and y-axis is the energy consumption. The training stage is more or less considered flat, but the challenge comes from the inference stage. As more and more people start to use this capability and the number of users increases, which we'll see this grow tremendously. If we put these two things together, aggregate amount of energy consumption is going to be going up as the AI has been used by more and more users. And so this is the things which we will see as, at least for me, is a hypothesis. We still have not any solid data to prove this, but intuitively this is the way it should be. But look at the energy consumption is going to grow, but does that mean the carbon emission will grow as well? Actually, my hypothesis is it may not. So remember, Prof. Bowden mentioned in his talk that although the data center workload grows tremendously, the energy assumption actually stay roughly is the equal. It's because we can do technology advancement in terms of energy consumption as well as the carbon, have developed more green computing technology. So actually, recently in data center industry, people start to think about, rather than power my data center using electricity or generate from the natural gas, how about we using the electricity generated by the hydrogen? So actually, a leading trend in the industry right now, people start to look into using the hydrogen-powered data center. Actually, is some research project we are working in Singapore. It's actually we're building a 3 gigawatt hydrogen power plants in an island which is 40 minutes away from Singapore. I'm using that to power our data center industry rather than rely on our traditional power grid to power these data centers. So then this will be complete green data center. So reduce the carbon emission of this computing infrastructure to the minimum. And because Singapore, we consider as a nation, only thing we have is talent or these computing resources we can put somewhere to generate the economic activities rather than grow in a certain aspect. So actually, this is something we have been doing. So this one aspect of this story. So this digital transformation and AI will lead to carbon emission, will lead to these sustainability challenges. But at the same time, AI as a tool, and digital tools, we can call it, actually it helps with this address the sustainability challenge in our industry, in our economics as well. So that's the other side. How can I leverage the capability of AI to help me to address some of these sustainability challenges? So actually, let me look at the one specific application domain. It's what I call industrial AI. It's a special term we use to refer that an application of AI solutions in the physical operations of systems, for example, these office, data center, factories, power plants of an organization. And it's focused on the helping the organization digitalize, optimize, and automate their operations and systems to improve the energy efficiency and performance. So this one particular research area people have been using a lot. So actually, if you look at this, so the question here is, can we leverage this industrial AI to transform in physical infrastructure, which often consume a huge amount of energy? So actually, if we focus on the right-hand side, actually the left-hand side is the business AI. So we use that to address the customer and employee. Is less of interest to this topic. Let's look at the right-hand side. It's the industrial AI, to use AI techniques to transform how we operate this infrastructure, and especially in physical space. We also have some project with ADDB to look into this. I look at 4 particular areas. I call it F4, like factories, field, fleet, and facilities. And all of these industries have the same challenges. By using AI, we can improve its operational efficiency and reduce the amount of energy consumption. And hopefully, by doing this, we can improve its energy efficiency by properly address the energy metrics mix. We can reduce its carbon emission as well. Both look at the reduce carbon emission in the operational efficiency, as well as using new technology as a substitute of the energy source to actually remove the carbon emission from these operations. Let me use an example. So actually, inside this, I developed a technology called industrial metaverse. Actually, specifically for data center industry, we're trying to use AI to reduce its operational, to improve its energy operational efficiency. But challenge with using AI work with these physical systems is actually, it's not easy to have access to the operational data. So that makes my AI useless if I don't have data. Or a second, if AI gives some recommendation, if I directly send to the physical system, people often are reluctant to use AI recommend actions because AI is a black box solution. Often people don't trust them, so that's a second challenge. So to address these 2 challenges, we introduce a digital twin in the middle as a proxy to serve 2 purposes. First, digital twin, I can use that to synthesize operational data using physics-informed machine learning or whatever tools we have, and generate data for AI training purpose. At the same time, if AI recommend any actions, we can validate in this digital twin space. So we are confident that what are the pros and cons, what are the risk and cost analysis, we can decide whether we can use or not. So this a new paradigm we're trying to introduce in these physical infrastructure operations. And let's look at one example. So this is a data center with not the big one. It's actually 1.1 megawatt data center. We look at 2 aspects. First, we look at the CapEx. Rather than build this data center in the first place, we build in the digital space and validate the design and the operation conditions. So basically replace the physical build-up cost with a computing cost. I can reduce the physical cost, like equipment cost by 20 times, the carbon emission by 3,000 times. Also use the same digital twin, I can use that to operate the data center to reduce the operational cost like reduce the other metrics for data center operations called PUE, power usage effectiveness. It's ratio between the total facility power and IT power. It's number larger than 1 and closer to 1 as possible. So by doing this optimization, we can reduce the operational carbon emission annually. It's close to close to 1,000 tons for this smaller data center. So actually, with this digital twin-based and AI solution, one can possibly to reduce the power consumption and in turn to reduce the carbon emission of these operations. And that helped to answer Prof. Ma's question earlier. So how much we can serve by using AI? So actually, if we want to extrapolate this phenomena into the whole industry, if you look at the a sustainable future for AI and by AI. So we have actually a tussle between two forces. First, the red line showing the energy consumption by AI will roughly increase as the adoption increases. But at the same time, if I use AI to actually transform how I operate these infrastructures, and then I can see energy saving and also in return the carbon emission reduction as well. So here's my hypothesis. With my limited knowledge on course taken in econ. So as my adoption increases, the energy consumption by AI roughly is linear, we see before, and this saving will be actually increases as well. So then we'll go through a few things first. They will go through different stages. Initial seed stage, obviously we are paying a cost in terms of carbon emission and energy consumption. And the second stage is in the growth stage, and after that is the mature stage. We can see benefit of using AI for infrastructure management, so we can save more energy than we consumed by AI. So this is, and then we were trying to look for this inflection point. So beyond which AI adoption, the benefit or the net benefit of using AI is overtaking the energy consumption by the AI. So that's actually what and hypothesis I have offered to the econ community. Let's see whether we can prove or disprove this hypothesis with some data. And actually, we're trying to working with Alibaba team to actually have some joint project to actually collect data in a global stage, at least for the data center industry, to prove whether this is the this hypothesis is correct or incorrect. So this is the second and last slide. And last slide is something actually, as an AI researcher, my friend often asks me, so given these challenges of AI and sustainability, how do I do in this space? And what kind of things I need to do? So actually, how to enable AI in a larger industry sector, different industry sectors. So I came up with this AI worst product slogan. So what does that mean? An AI project in a vertical industry needs to look at 5 aspects. Assume that building an AI application in the industry is a moonshot project. Just for the sake of being, for the sake of argument, you allow me to use. So I need 5 components. First is the platform. It's the computing platform. Nowadays with AI GC, we need huge amount of GPU cards to compute. So I will need platform. Second, I'll need researchers. In a way, I call that pilot to drive my system and AI researchers. And third is the algorithm. I can say that roadmap. I have to develop a new algorithm for different applications. And the fourth one is the data. Data is the fuel of this rocket science, rocket. And last, often overlooked at is the application. So what application we're trying to use AI inside of my vertical industry. So, but for people from Singapore, anything beyond 3 is hard for us to memorize. So I take the first letter of these 5 words, I put them into a sequence called product. And happens to, when I first came out of this, I was in the airplane to watch the movie, the the Devil Wears Prada. I said, the AI wears Prada. So that's how we try to enable AI application in sustainability challenges of good timing. So with that, I'd like to conclude my talk, and later, if any questions, I can help to address. Thanks.